Section 5.5 is the reciprocal function family. Our goal is to graph functions expressed symbolically and show key features of the graph. On page 376, we have functions that model inverse variation, have the form f of x equals a over x, where x does not equal 0. They belong to a family whose parent function is the reciprocal function f of x equals 1 over x, where x does not equal 0. Transformations of the parent reciprocal function include stretches, compressions, or shrinks, reflections, and horizontal and vertical translations. The general form of a member of the reciprocal function family is y equals a over x minus h plus k, where x does not equal h. The inverse variation functions y equals a over x are stretches, shrinks, and reflections of the parent reciprocal function, depending on the value of a. The graph of the parent reciprocal function is y equals 1 over x, is shown at the right. An asymptote is a line that a graph approaches as x or y increases in absolute value. The x and y axes are asymptotes of the parent reciprocal function. Example 1 says, what is the graph of y equals 8 over x, where x does not equal 0? Identify the x and y intercepts and the asymptotes of the graph. Also state the domain and range of the function. The first thing we should do is check some values of x. I have two tables here, one with a lot of negative x values and one with a lot of positive x values. So let's take a look at the positive values. If we have 8 divided by 1/2, that gives us 16. 8 divided by 1 gives us 8. 8 divided by 2 is 4. 8 divided by 4 is 2. 8 divided by 8 is 1. And 8 divided by 16 is 1/2. Similarly, on the negatives, it's the same answers, just you throw a negative sign in there. The next step is to take all these points and plot them on the graph. Once you have plotted all of your points, you can draw the curves. Now, pay attention to the fact that this graph is labeled by 4s. So I went 4, 8, 12, 16 on all the axes. And you have to be careful when you're graphing 1/2 or 1 or 2. Notice 1/2 is going to be very close. It would probably be even closer than I drew it. That's just as close as I could get. And then 1 would be a little bit over. 2 should be right in the middle. 4 would be on the next tick mark. So this is our graph of y equals 8 over x, where x cannot be 0. Notice that x cannot be 0, so there is no y-intercept, so we're never going to actually touch the y-axis. The numerator is also always 8, so it will never be 0, meaning y will never be 0. So there's also no x-intercept. This tells us that the x-axis is a horizontal asymptote, right here, and the y-axis is a vertical asymptote. Knowing the asymptotes will provide you with the basic shape of the graph. Now, our x values, as you can see, we picked a whole bunch of them. They can be anything except 0. So our domain is going to be all real numbers except 0. And then the range, similarly, we said that we're never going to have 0 on the top of our fraction. So we can't get the value of 0 for y, but we can get any other value. So the range is a set of all real numbers except y equals 0. So here is all that information written out. The work for that is on the next few slides. And now I have a u-try. I would like you to graph the function, identify the x and y intercepts and the asymptotes of the graph, also state the domain and range of the function. You have y equals -3 over x. Keep in mind what we talked about with the numerator being something other than 0 when it comes to looking for the intercepts.